Hello everyone, I am Parva Shah, and I am currently pursuing my Masters in Construction Engineering and Management from SEPT University. In this portfolio, I have compiled some of the topics of our group work for Studio 3 Integrated Construction Practices. Objective of the studio is to study, understand, and address the challenges faced by the conventional AC industry and compare it to the integrated project delivery approach, and use BEAM and Lean tools to solve these challenges. For this studio, high-rise residential project situated in Ahmedabad was selected. It is a premium 3 and 4 BHK residential project of G plus 20 story and it comprises of two basements. Total area of project is around 7,072 square meter and duration of project is around 36 months. For the studio purpose, 11th, 12th and 13th floor of Block D was chosen as scope of work for 3D beam modeling and 15th and 16th floor was chosen for LPS implementation. In this studio, each of us were assigned different roles like architecture, structural consultant, MEPF consultant, beam coordinator, and contractor. I chose to prefer role and responsibility of structural consultant and firefighting consultant. For developing level of development versus level of schedule, first we have to define targeted LOD level for each of the model. So for here, targeted LOD level for architecture model and structural model is LOD 300 and LOD 400, and for MEPF model, targeted LOD level was LOD 300. LOD versus LOS provide us detail about who will be the author of particular element or activity and who will be using it, and in which week that element or activity is assigned or to be executed. It helps to set up and align the stakeholder engagement in early stage of project planning. And it also provides precise flow of the project and it is easy to track weekly PPC using LOD versus LOS. To prevent the structure LOD 300 model, process flow of that is as shown in here. For that, first the 2D drawing was obtained and studied, and after that the spatial element like grid, levels, project base point and survey point was created. After that 2D drawing was linked to that model. Here are some model elements for the LOD 300 level of structure model like shear wall, beam, staircase, refugee slab and column. This figure shows the LOD 300 model of the structural element. This slide shows the LOD 400 model of 12th floor and this figure shows reinforcement detail of the various structural elements. Here this figure shows the process flow adapted for the firefighting 300 model. This table shows plant start and finish date for the LOD 300 firefighting model. Various elements of the firefighting model was wall mounted hose reel box and the fire pipe. This figure shows the rendered LOD 300 model of firefighting level. The major constraint faced during firefighting model was unavailability of firefighting drawing and the section drawing was not available in the provided drawing and also lack of information on height of fixtures. After each model was prepared, some quality checks are performed, like visual checks, interference checks, standard checks, and model integrity checks on various software like Revit and Navisworks. These checks are performed to ensure the model is error-free and as per the client request. After each model was prepared, quantity takeoff has been done for the model from Revit. Here, quantity takeoff of MEPF service are shown. Procedure for quantity takeoff is as shown in this figure. Here for mechanical model, quantity takeoff was done for indoor unit and outdoor unit. For electrical model, conduits, junction box, fixtures and fitting. For plumbing model, various pipes, fittings and fixtures. And for firefighting model, pipes and the fixtures. Here are the sample quantity takeoff of mechanical element, electrical element and sample quantity of plumbing elements. Process flow of 4D simulation using Navisworks is as shown in this figure. For the 4D simulation, scope of work was selected as 15, 16 and 17 floors. This image shows the 4D simulation in Navisworks. And the red outline portion in above figure shows the percentage completion of various activity and overall percentage completion of the project. This helps to track the daily PPC of project and productivity. Also in Navisworks we can track the project live. Also this figure shows the appearance profile of various activities. The visualization of construction sequencing, which aids in resource and schedule optimization and make it simple to reduce conflicts between different activity, is one of the major benefit of 4D simulation. Here sequencing of RCC work of one floor and architectural work of lift lobby was prepared using Synchro 4D Pro software. And the schedule of that activities is shown in this table. Firstly, the part 1 column was casted and after that the part 2 column reinforcement and shuttering work was done. After it is completed, the beam bottom shuttering work started and then slab shuttering work reinforcement work started. After the whole slab is casted, block work and plastering of lift lobby was started. After that, flooring and door installation, and after it is completed, painting and wall marble insulation at shear wall, and the skirting is done. Legend of each of the activities is shown in this figure. To see the 4D simulation video, please scan this QR code. So basically, Studio 3 ICP deals with the adoption of integrated project delivery approach for achieving successful project goals. As traditional construction process operates in a more segmented and hierarchical manner, the integrated project delivery approach prioritizes collaboration and integration. IPD seeks to break down barriers between disciplines and fostering a collective mindset among stakeholders. This shift toward collaborative practices can lead to more efficient project delivery, reduced conflict, and ultimately greater success in achieving project goals. Here are some of the key learnings of each of the deliverables. Thank you.